All right, let's continue with the radical equations. So let's look at this example. Square root of x minus 4 equals to minus 5. So we're going to go through and the process, the method to solve this. We're going to square both sides. The radical is already isolated, so I'm going to square both sides. And let's go ahead and solve. So we get x minus 4 equals to minus 5 squared is 25. And then solve for x. X is equal to 29. All right. Now, we need to check. Let's check our answers. Plug it back into the original. So square root of 29 minus 4. We're going to check if that is equal to negative 5. That's what we're doing. We're checking that to make sure it works. Well, square root of 25, is that equal to negative 5? No, it is not. Okay, so square root of 25, that's a positive square root of 25. That should say positive 5, not negative 5. So this answer doesn't work. Okay, so this is, we call this an extraneous root. That means it just doesn't work. This equation, another way of writing it is that this equation has no solution. So this equation has no real solutions. Now when I say real, is based on the real number set, the set of all real numbers, because this equation does have a solution. It's not based on the set of all real numbers. It's based on set of complex numbers that it's beyond the scope of this course. All right, so that's the first example. Let's look at another example. Okay, so look at this example here. We are having three terms. Left hand side 2 plus square root of x plus 1 equals to square root of x plus 2. Now in this case, you already have the radicals isolated. There's nothing you can do. You have three terms. One of the terms is not radical. So the first thing that you have to do, you just go ahead and square both sides of the equation. Now this is the part you have to be very careful. When you do this, you need to make sure that you are doing the operation properly. So this bracket squared is basically 2 plus square root of x plus 1. Again, you're multiplying that twice by itself. That's what the exponent 2 is. The other side, the x plus 2 comes out of the radical. Great, but we need to go ahead and simplify this, and when we simplify that, we get 4 root x plus 1 plus then the square root of x plus 1 times itself is x plus 1. That equals to x plus 2 on the other side. So remember, you have to distributive law, the FOIL, right? You got to do that. That's what we got. Now we're going to go ahead and simplify. So by simplifying, what we have is that root. So I'm isolating. Basically, we're going to isolate the radical again. This is a very hard question, so you have to do the isolation twice, really. So what we have is a plus, and then we have x plus 5 because of 1 and 4 right here. And then the other side is x plus 2. Very good. We're going to continue 2 times x plus 1 square root. And then we're going to bring all the x's and all the other numbers to the other side because we want to isolate the radical term. So what we have here is that x and x cancels out. So we get negative 3, 5, minus 5 from both sides. You get negative 3. And now we're going to go ahead and raise again because we want to simplify the radical operation. To undo it, we have to raise to the power of 2. Now you already see what is happening. This square root has a negative answer, so you know the square root, a positive square root, will not have a negative answer. That doesn't work. That's extraneous root. But you don't stop. You will have extraneous root, but you need to find out what that is. So, alright, so once we square both sides of the equation, so on the left hand side we have 4 times square root of x plus 1, and then on the right hand side is we have minus 3. We square both sides and we will get 16 times x plus 1 equals to 9. Now you already know that we can multiply this through and do the distributive or the distribution. You isolate the variable x, okay, and here final answer x equals to -7/16. Now here's the part where you have to be very careful. You need to check. Now before moving on, I need to make sure that you already see that this equation will not have a real solution, because a radical equation, a radical term cannot be having a negative value. Okay, so in the left hand side we have a radical equation there, or radical term. The right hand side we have a -3, and a radical cannot be, the value of the radical cannot be negative. So now when you checking, you plug the numbers -7/16 in, and when you do that you get, so remember, the -7/16 goes back into the original. This is the original equation right there, okay, without the squares, okay, the original. And then when you do that, you'll get, you go through the math and then you simplify, you'll get 2 plus 3/4, because 9/16, the square root of that, as a perfect square number, so that would be 3/4. The other side, when you do the subtraction here, -7/16 plus 2 is basically 32/16. That's what that is. Same denominator. When you do the subtraction, you get 25/16, because 32 minus 7 is minus 7 is 25. So here it is. Is this true? That's what you're doing. You're checking this. Is that true? No, it is not true. Okay, 2 plus 3/4 is not equal to 5/4. That's not true. Therefore, we say this is an extraneous root. That means that this radical equation, the equation has no real solutions. And when I say real, a set of real numbers over the set of real numbers. And the set of real numbers are everything that you know. This equation does have a solution. It's just that it's not based on the set of real numbers. It's based on the complex set of complex numbers, which is the beyond the scope of this lesson. Okay, so here it is. This is a very complicated question, and you just have to practice. Follow the process, follow the method. Make sure you don't make any algebraic mistakes. By the way, I did make a mistake, but I went back and stopped the video and actually retraced my mistake, and that came right here when I expanded right there. When I expanded it, originally I didn't expand it properly, so you have to go through and make sure that you don't make a mistake, and then you check your final answer, and then you make sure that based on that, does that answer works or it doesn't work. If it doesn't work, then make sure it's extraneous root, and if it does work, then you have the final answer. By the way, this one's supposed to say 25/16, and that's 5/4. That's what that is. Okay, practice time. Square both sides on that one.